Good morning, dear students. Today we are going to start with chemical properties of aldehydes and ketones. As all of you know that aldehydes and ketones are highly reactive compounds. Since both of these classes of organic compounds have the same functional group, that is the carbonyl group, and they show a number of common reactions. However, the presence of hydrogen atom on the carbonyl group of the aldehydes makes them much more reactive than ketones. So let's discuss. When we talk about the reactions of aldehyde and ketones, then they are divided into following categories. Nucleophilic addition reaction. So we will see nucleophilic addition reaction, addition of water, addition of alcohol, then addition of hydrogen cyanide. Second type of reaction is addition reaction followed by elimination reaction. In this, you will see addition is there as well as elimination of a small molecule like water or ammonia will take place. So in this, mostly we are going to see the addition of ammonia and its derivatives. So addition of ammonia, addition of hydroxylamine, addition of hydrazine, phenylhydrazine and 2,4-dinitrophenylhydrazine. This is also known as 2,4-DNP. In NCERT, one question is there in which they are asking the reaction with 2,4-DNP. So this DNP is nothing. It is dinitrophenylhydrazine. Then you will see the reduction of aldehydes and ketones. In reduction of aldehydes and ketone, you will see how the aldehyde will reduce to convert back to alcohol and ketones to the secondary alcohol. In alcohol phenols, you have seen the oxidation. Here, you will see the reverse process of reduction. Next is oxidation of aldehydes and ketones, which will give rise carboxylic acid, or few tests are there in which you will see how the oxidation will tells you about the presence of aldehydes and ketones. These reactions you will do in the practicals also. And next is the reaction involving alpha hydrogen. So few reactions are there which will take place if the alpha hydrogen is present, and few reaction will take place if the alpha hydrogen is not there. So in that category, the reactions are aldol reaction, which is very important, Perkin reaction, benzoin condensation and Cannizzaro reaction. So this aldol condensation and Cannizzaro reaction, these two are very important reaction which usually asked in the exam. So when we talk about the nucleophilic addition reaction, both alkenes, aldehydes, ketones, alkenes also because they are having carbon-carbon double bond, aldehyde having carbon double bonded oxygen, and ketones are also unsaturated compounds, so carbon double bonded oxygen. So unlike alkenes which show electrophilic addition, aldehydes and ketones undergo nucleophilic addition reaction. And in this, the carbonyl is quite polar because of difference in the electronegativity. And the mechanism we have seen in the last video, that nucleophile will come to attack here at this carbon. Breaking of double bond will take place. So here you can see nucleophile attacked and the addition product is obtained. And when this addition product is there, they are generally alcohols. Addition products are generally having the OH group. So first one is the addition of water. Water can add to a carbonyl group to form diols. They are known as diols because having two OH group. And they are known as gem diols, or they are also called as hydrates because the carbon having two OH groups. And as I told you many times, carbon having two OH group is unstable, cannot be isolated because there will be the removal of water molecule. And again it will come back to the ketones or aldehydes. So when there is addition of water, they react with water and form the diols. So you can see if the carbonyl group is there, this carbonyl group, double bonded carbon, react with HOH. So what will happen? This H will go with O and OH nucleophile attack here. So this carbon is having two OH bond, but it is unstable because there is removal of water, and you will get the this is the reversible reaction. This is reversible reaction because when it will remove the water, again it will come back to the ketone. Next is the addition of alcohol. So in this you will see formation of acetal and ketone. Aldehyde reacts with one equivalent of monohydric alcohol in presence of dry hydrogen chloride gas. Means the reaction will be in acidic medium. You can see here the reaction medium is acidic. To yield alkoxy alcohol intermediate, which is known as hemiacetal. Then this hemiacetal react with one more molecule of alcohol to give gem dialkoxy compounds known as acetal. And when ketones are there, then it will be the kettles. So formation of acetal and kettle takes place. So addition of alcohol to the carbonyl group of aldehyde in presence of strong acid give rise hemiacetal as an intermediate and acetal as the final product. Similarly, hemikettle and kettle will form. So you can see in the reaction, when there is reaction of alcohol, then one bond will break and H will attack here. So here OH will come and OR will attack on the as a nucleophile on the other position. So this is the hemiacetal. Again when water molecule will attack, then there is removal of H2O. This H2O will be removed and OR group will be there. So if one OR group is there, then it is hemiacetal. If two OR group are there, then it is known as acetal. Next is addition of hydrogen cyanide. Both aldehydes and ketones add a molecule of hydrogen cyanide to form cyanohydrine. This compound is known as cyanohydrine. We can see the reaction here, RCHO aldehydic group. When HCN will be added, then what will happen? R, H will remain as, and this double bond will open up and O negative. So H will go with oxygen and CN will go here. So you can see R at this carbon, CN is there and OH is there. That's why this is known as the cyanohydrine. This compound is known as cyanohydrine. So if instead of R, if we are taking acetaldehyde, CH3 CH double bond O, and when HCl will be added, then what will happen? The product will be CH3 HCO. So H will come here, CN will come here. So if it is acetaldehyde, we call the product as acetaldehyde cyanohydrine. Acetaldehyde cyanohydrine. If your reactant is ketone, for example, it is CH3 ketone, right? So your product will be acetone cyanohydrine. In this way, the presence of OH and CN group together form the product known as cyanohydrine. Next is addition of Grignard reagent. So, aldehydes and ketones react with Grignard reagent, that is RMgX. This is the Grignard reagent to give the addition product, which on hydrolysis gives the alcohol. So final product will be alcohol. The type of alcohol formed depends upon the aldehydes or the ketones used. For example, we have taken acetaldehyde and we have taken any type of Grignard reagent. Here we have taken methyl group. Instead of methyl, you can take any other group. Clear? So when acetaldehyde react, then first of all this double bond will break. So CH3C CH3 C H will be here and double bond like this. So what will happen? Oxygen is here, which is negatively charged, and magnesium is positively charged. So MgX will come here and your alkyl group, whatever it is, will come on the other side. Then you will get the intermediate product. In this case, this is iodomagnesium, or this halogen can be chlorobromoiodo. So here it is iodo, that's why it is iodo isopropoxy magnesium. Now this is mandatory to have the hydrolysis of this product. Hydrolysis in acidic medium, addition of water. So when water will be added, HOH. So MgX and OH will remove as the byproduct, and H will come here with the oxygen to form the alcohol. So you can see here in this reaction, second step, when the addition of water is there, so Mgi and OH will be removed and one of the hydrogen will come here and form the alcoholic group. So with acetaldehyde, 2-carbon aldehyde gives you propane 2-ol. This is ascending of series. Means in conversion, if you want to increase the number of carbon from aldehyde to alcohol, then you can use the Grignard reagent. Second type of reaction is nucleophilic addition reaction followed by elimination of water molecule or a small molecule like water or ammonia. In these reactions, you will see the removal of water. When aldehydes and ketones react with a number of ammonia derivatives such as ammonia, hydroxylamine, hydrazine, phenylhydrazine, 2,4-DNP. We call it as 2,4-dinitrophenylhydrazine, which is also known as Brady's reagent. The name is Brady's reagent. You will see in the next coming slides. Semicarbazide, all these reagents can be added with the removal of water molecule. So nucleophilic addition to the carbonyl group followed by the elimination of water to form the product containing the double bond. First one is the reaction with ammonia. So you know it very well, ammonia is NH3. Here it is HNH2. You know this, we can write in this way. So what will happen? This double bond will break. carbon oxygen double bond, pi bond will break and the valency will be free. So what will happen? This H will attach to the negative oxygen and NH2 will attach here. So you can see the formation of this addition product. Now there is removal of water within the molecule. So this OH will be removed along with one hydrogen and double bond will come here. So you will get the product which is known as the addition product followed by the elimination. So this is the imine. This product is known as the imine, not amine. Amine is NH2 group. Here it is known as imine group. Next is reaction with hydroxyamine. It's exactly hydroxylamine. We call it as hydroxylamine. So aldehydes and ketones react with hydroxylamine to form oximes. So reaction is there with the formula. This is the formula of hydroxylamine. You can see one hydrogen of ammonia gets substituted by OH. H is removed and OH is there and we are calling it as the hydroxylamine. So what will happen when hydroxylamine is added? Oxygen of carbonyl carbon and hydrogen from the hydroxyl group will be removed as H2O and this carbon gets bonded with the nitrogen. So the coming product or the product obtained known as oxime. If we have taken ethanol, then it is ethanol oxime. You know it, this is acetaldehyde. General name is acetaldehyde. That's why it is written acetaldehyde oxime. You can also call it as ethanol oxime. If it is propanol, then propanol oxime. If it is methanol, methanol oxime. In this way, you have to add the word oxime as a suffix in the parent name, whatever the reactant is. So I hope it is clear. Next is the reaction with hydrazine. Hydrazine is NH2 single bond NH2. Hydrazine on reaction gives rise the product known as hydrazones. Hydrazine to hydrazone. Aldehydes and ketones react with hydrazine to form hydrazone. Remember the formula of hydrazine, that is NH2 single bond NH2. Again there is removal of water molecule and this carbon gets bonded with the nitrogen and you will get the hydrazone. If it is acetaldehyde, then it is acetaldehyde hydrazone. Its IUPAC name is ethanol. So ethanol to ethanol hydrazone. In the same way, other reactant, for example methanol, methanol hydrazone. If it is propanol, then from here it is propanol, then your product will be called as propanol hydrazone. You have to add the suffix hydrazone with the main name of the reactant. Next is the reaction with phenylhydrazine. Phenylhydrazine is nothing. In hydrazine NH2 one hydrogen gets replaced with the phenyl group. You can see here NH2. So one hydrogen get replaced by the phenyl group. So we are calling it as the phenylhydrazine. So this oxygen and water H2O. This H2O gets eliminated and the bond will be formed with the name acetaldehyde phenylhydrazone. As you know in the previous reaction, hydrazine gets converted to hydrazone. So phenylhydrazine gets converted to phenylhydrazone. Now you have to add the suffix phenylhydrazone. If your reactant is methyl, then you have to add the phenylhydrazone. If it is the ethanol, then your product will be ethanol phenylhydrazone. If it is propanol, then your product will be propanol phenylhydrazone. In this way, you can form the various products. Now, next reaction is the reaction with 2,4-DNP. 2,4-DNP is 2,4-dinitrophenylhydrazine. In this, the formula is like hydrazine only. Instead of hydrogen, you have to add the phenylhydrazine group, 2,4-dinitrophenylhydrazine group, which I have encircled, that is 2,4-dinitrophenyl group. Clear? So what will happen when the aldehyde or ketones react with 2,4-DNP? The same way H2 gets eliminated and you will get the product in which the suffix is 2,4-dinitrophenylhydrazone. It means phenylhydrazine converts to hydrazones. I hope it is clear. The same way ethanol will give you ethanol 2,4-dinitrophenylhydrazone. If it is the propanol, then you will get the propanol 2,4-dinitrophenylhydrazone, and so on. Here I have summarized all the reaction of the ammonia and ammonia derivative. So directly you can see here the formation of the imine, that is reaction with ammonia. You will get imine. Then hydroxylamine, you will get oxime, hydrazine to hydrazone, phenylhydrazine to phenylhydrazone, 2,4-DNP to 2,4-dinitrophenylhydrazone, semicarbazide to semicarbazone. So all these are the derivatives of ammonia, which will give you the addition product with the elimination of water molecule. Now next we will see reduction of aldehydes and ketones. Reduction of aldehydes and ketones to form alcohol and alkanes means reduction, you will reduce aldehyde ketones to alcohol. As you know very well, that is the reverse reaction. You have seen in the alcohol get oxidized to form aldehyde and ketone. So aldehyde and ketone get reduced to form alcohol. If it is the case of ketone, it get reduced to 2-degree alcohol, and if it is the aldehyde, it get reduced to 1-degree alcohol. It can reduce to alkanes also depending on the reagent. So catalytic hydrogenation, that is addition of water in presence of palladium, platinum, others are there, you will get the alcohol. Reduction with the strong reducing agent, you can get the reduction of the ketone. So you will get the 2-degree alcohol. Now Clemmensen reduction and Wolff-Kishner reduction. Two more are there by which you will get the alkane. Let's see. Aldehydes reduction and ketone reduction to produce alcohol. Here you can see the flow chart in which it is clear that primary alcohol oxidized to aldehyde and aldehyde reduced to primary alcohol. Secondary alcohol oxidized to ketones, and ketone when reduced converts to secondary alcohol. It means aldehyde reduces to form primary alcohol and ketone reduces to form secondary alcohol. Now the reduction by which we will get the alkanes. So first one is the Clemmensen reduction. When we talk about Clemmensen reduction, it involves the reduction of aldehydes and ketones with zinc amalgam and concentrated hydrochloric acid. So the reactants which are more reactive with the acidic medium, they react with the Clemmensen reduction and form alkane. You can see the reaction in presence of Zn, Hg and HCl. There is formation of alkane. But if you will see the next reaction, that is Wolff-Kishner reduction, in this aldehyde or ketone is heated with hydrazine and KOH or potassium tertiary butoxide to form alkanes. Wolff-Kishner reduction is used when the carbonyl compound are sensitive to acid. That's why they use the basic medium. But if the Clemmensen reduction is there, they are widely used for the reduction of aldehydes or ketones which are sensitive to alkali. That's why they are using the reagent acid. Both are same, only the reagents are different. They will give you the same product. Clemmensen and Wolff-Kishner. You can compare it. You can see both the reactants are same, both the products are same. Only the difference lies in the reagent. If the compound is sensitive towards the alkali, then Clemmensen. If sensitive towards the base, then it is the Wolff-Kishner. Next reduction, that is Mervin-Ponndorf-Verley reduction. This reduction is not very much important, but it follows few rules. That's why it is in your NCERT. So in this reaction, carbonyl compounds are reduced to the respective alcohol by treatment with aluminium isopropoxide in isopropanol solution. So here the reagents are aluminium isopropoxide with isopropanol. So you can see the reaction. In this reaction, 2-propanone in presence of this reagent means acetone will convert to alcohol 2 degree. So this is one of the good method for the preparation of 2 degree alcohol. But the reagent should always be aluminium isopropoxide and isopropanol. Thank you. God bless you. The next reaction, that is from the oxidation reaction, aldol reaction, Clemmensen reduction, Perkin reaction, and many other reactions are left over that we'll see in the next video. Keep revising. Thank you and God bless you.